Okay, hello everyone. Hello friends. Yeah. So you can see the question, first question here, flashed here. I want you to solve, and those who have got the answer, say that you have got the answer. Don't tell the answer. So you have ground wave, sky wave. Okay. So you have sky wave and you have space wave. So the range of this becomes important. What is the range of ground waves? Few kilohertz. You check out whether I'm right. To what? Approximately, say 1 or 2 megahertz. And what about sky wave? Anybody? Hello? See, you are wasting your time. Come on. See, I told you yesterday. See, questions will be asked like this. So those numbers are very, very important. Yes, we can open your book and see. You can open the communication textbook and see there. Few kilohertz to few, I have written here. Few kilohertz to 1 or 2 megahertz I have written. Is it not okay? Yeah, it is few. See, it cannot be in hertz. It should be few kilohertz to 1 or 2 megahertz. What about sky waves?
3 to 30 megahertz.
Excellent. See, you should remember this. 3 to 30 megahertz. What about space waves? Right? Above 30 hertz. Above 30 megahertz. Correct? So this is all a boundary. Boundary is not well defined. It is approximately. It's a modulated. So therefore now you see this 10 megahertz falls in this range. Okay? Hello? Now here you see. Here you see suitable beyond horizon of communication. Beyond horizon using sky waves means this is the sky wave. See, Earth is like this. You know what is horizon? If you go and stand in the seashore, you can see the horizon. So if you want to communicate to somebody who beyond horizon, then the best thing is you should go in for the sky waves. And 10 megahertz is the thing. So B is the answer. Okay? Yes, sir. Be quick, be sharp. Now think that you should get into the examination mood now when I am solving these papers. Try to. Okay, so beyond horizon, high energy signals. 1 gigahertz can penetrate this one. 10 megahertz frequencies get reflected, hence such a see. Explanation is given for all these things. But anyway, they have told sky waves, so I did not see any other option. I saw the range of sky waves and I marked B. Okay?
Yes.
Right. Frequencies in UHF range normally propagate by means of ultra high frequency. Ultra high frequency means it is in hundreds of megahertz to gigahertz. Obviously, which is in space waves.
Yes, sir.
Okay? Right. Okay?
Yes.
Right. I am getting only 1 or 2 students yes there. Others don't have hum even to say yes and no. Who these fellows? Digital signals. Answer this carefully. So do not provide continuous set of values. Right? So 1 is okay. Represent values at discrete steps. 2 is also okay.
Yes, sir.
Then can utilize binary system. 3 is also okay. Can utilize decimal as well as binary. No, 4th is not okay. So which of the above? 1, 2 and 3, but not 4.
Even it can use the discrete decimal system.
Pardon?
With decimal system, sir. You can have a discrete decimal value.
That is the point. So that means you didn't understand the difference between decimal and binary system. Good, good. I appreciate your question. Can anybody explain, Adil? See, come on, let's have a healthy discussion in this classroom. Can anybody explain, Adil? Hello, say no at least, so I can explain. See, what it means, Mr. Adil, is now, see, if you say decimal system, decimal, that means you have got 10 what? 10 symbols. Binary means you have 2 symbols. Correct? You have got 2 symbols. Now, here you see, now if I say from this value to this value, say this value to this value, if I now say from this value to this value, that is, now I say the digit can have this value or this value. Okay, this value or this value. Okay, so if I have a binary system, I can say either this or this. Okay. Now, if I say it can use decimal number system, that means I can have 9 values in B. Got it? So it can have no, wait a minute. It can have any 9 values, any of the 9 values. Okay. Now you see, we are going in for digital communication. We are going in for digital communication precisely because, I'll tell you, you will understand this now. Precisely because, now you see, now understand this. I have got an analog signal. This is an analog signal. Assume that this is an analog signal. Okay. Now, if a noise penetrates into the system, so that noise can penetrate like this. That means now the signal is distorted at this point. Can you see here? Did you understand what I have written? Hello Adil, are you there? Why are you keeping quiet, man? What is wrong with you? So you see, this green one, what I am telling, see this white color what I have written is a signal which contains information. This green color thing is an external noise that has crept into the system. That means now your analog signal is now corrupted here. Got it? So, and usually noise will be small percentage of the original signal. You can see here, this chink is a small percentage of this. Okay. So therefore now at this point, the signal will now start looking like this. The signal will now start looking like this. Okay. The wholesome signal will start looking like this instead of the original signal. Correct? So now here you see this channel. Now supposing I convert this signal into a digital signal, that means now I will see digital signal means this value, this value, this value, this value, this value are all coded. Coded means you will get like this. You will get it like this. Okay. So what happens here is, you know, if there is a noise here, this digital values are say 0 to 5 volts. Normally 0 to 5 volts. And this chink what you see here is just a few millivolts, say even 10 millivolts. So the 10 millivolts cannot fit between 0 to 5 volts. And even it fits, it is very, very insignificant compared to 5 volts or even 0 volts. Okay, so the noise threshold increases with the digital signal. Okay, and that is an advantage of the binary system. If we go for octal and decimal and all, we lose this advantage. Okay, so therefore we cannot go for that. Correct? So the answer, Abhikula, don't try to. If you irritate me like that, then I have no other choice, because I want to make the system efficient. I want to solve as many problems as possible today. Understand? Okay, and close this chapter today and move on to the next chapter tomorrow. Otherwise, today's class will get extended tomorrow. You are the losers. That is why I am worried for you, not for me. Right. So which is the option here? C is the option. Okay? And whatever shouting I did now, for Adil it is applicable to everybody. He is a good boy who is learning. I want everybody to interact. Now going for the next question. Is it necessary for the transmitting antenna to be at the same height as that of the receiving antenna for line of sight communication? You answer the first part. Is it necessary for the transmitting antenna to be at the same height as that of the receiving antenna for the line of sight? Come on, answer this.
So it's not necessary.
Why?
If the height is more, then the line of sight will be faster, sir. But it will not affect the transmission.
Okay, somebody else can also give some answer to this. So come on, you should now become some sort of engineers also, right? See, your thinking, your imagination, you should be able to sketch it and then comment on that. Okay, that's the best way to answer such questions. So as soon as I read the question, to my mind, I will get this picture. Okay, I'll get this picture. So for me now, this is Earth, and supposing I have an antenna here. So this is the transmitting antenna. Assume that this is a transmitting antenna. And I wanted to receive. So, well, I will have a small antenna here. It's okay. I can still have the line of communication. So the antenna size, so this is large, that doesn't mean that this should also be large. So it is irrespective of this height for the line of sight communication. Correct?
Yes, sir.
So line of sight means, you see, from this end I should be able to see this. I should be able to draw a straight line with no obstacle in between. Okay? So therefore, it is not necessary. Okay. A TV transmitting antenna is 81 meters tall. How much surface area can it cover if the antenna is if the receiving antenna is at the ground level? Come on, again this also you can sketch it. Okay, so you have the antenna. Okay. So he is asking you how much surface area it can cover. It is 81 meters. That means now from this tip you draw a tangent to this sphere. Hello, are you with me?
Sure.
So you draw a tangent to this. You draw a tangent to this. Okay, right? So it is touching this at these 2 points A and B. I am showing you A and B, but actually this is what? This is going to be a circle. Correct?
Yes,
So therefore now all this area means I have something, I'll show you. Come on, you work out the problem. It will work out. See, now you can find out. Okay, if this is the antenna, hello, we can see this. So this point this point. That means this entire area it can cover of this sphere. Right?
Yes, sir.
So you have to calculate that area. That's it. That's your challenge. So now your coordinate geometry will come into use. So what is your coordinate geometry now? So you must now think about a cone like this. This height is 81, right? So I've taught you spherical coordinate system. Have I taught you spherical coordinate system?
You just said that in the exercise.
I didn't teach. Okay. So a bit of that can help you. I think you should have learned now in mathematics. 3D coordinate geometry you got now. You might have got cylindrical, spherical coordinate system. It is there. It is there in the syllabus. Anyways, so now you see. You can apply to it. But this is now you have to see 3D. You have to see the 3D here. You have to see now this area. You have to calculate this area. Service area is this, not circle. So for that, so you see, this is the theta. It is going to be, that is this point. This point. So if you are able to find out this theta, then your problem is solved. Okay, so this is 81 centimeters. 81 centimeters from here. Sorry, 81 meters from here. Okay, and this is Earth, isn't it? So this will be 6,400 kilometers. So 81 plus 6,400. This is the height. Hello, are you with me? And I told this is the tangent. That means this and this is the radius. So this is 90 degrees. Okay? And again this is the radius 6,400. So you take this R and you take this 81 and again this is R. Right? So can you get this angle theta? You can. This is 90. So this is 81 plus R. This point is O. This point is O. This point is say A, B, C. This point is C, and therefore this point should be B. And this is R. So I am asking you this theta. Simple. Cos theta will be R by 81 plus R. So you can find out theta. Correct? Hello?
Yes.
So you can find out theta from this. Right? Theta. Right. Now you work with me, maybe. I may be right or wrong. That is not, that is, you have to work with me, then only you will understand the solution. So that is the theta. Now I'll teach you spherical coordinate system. So it will be handy for you in many other things that you are going to learn. See students, I think I have taught you cylindrical coordinate system.
Yes, sir.
Yeah, good. So that means now you see in the Cartesian coordinate system you have got a point P, X, Y, Z. Right? Cartesian coordinate system. So in Cartesian coordinate system you're going to have it like this. Right? So you take it as X, you are taking it as Y, and you are taking it as Z, and there is some point P here, and some point P here which is X, Y. Right. Now, if you quickly tell me what is this XYZ, life will be jingalala for you and me. Fast.
Sir, please can you repeat the question?
What is XYZ in this Cartesian coordinate system? I have taught you. What is XYZ?
It will represent the distances you need to move from the origin in the direction of the x-axis, y-axis and z-axis to reach that point.
Distances from where you will move?
From the origin.
No,
from
wrong. Anybody? I have taught this several times. See, that's what I am telling. Conceptual clarity. You should go to the grassroots. Okay, now quickly I will tell you the grassroots. First of all, understand what is Cartesian coordinate system. What is Cartesian coordinate system? Okay, how do you get the Cartesian coordinate system? You will take a plane. You will take a plane, right? You will take a plane. Can you consider this plane? Hello?
Yes, sir.
So I will call this plane infinite plane, the wall behind me, infinite plane, and I will call it as x plane. X plane. Then I will take another plane which is perpendicular to this plane. That is like this. It is perpendicular to this wall. Hello, are you with me?
Yes,
Perpendicular to this wall. Okay, I will call this as say y plane. I will call this as, if I call this yes x plane, I will call this as y plane. Okay, then I will take the third, all are infinite. I will take the third plane which is like this, horizontal. The third plane is horizontal. Correct? And I will call this as z.
Yes, sir.
Understood now? So now here you see the floor on where I am standing becomes the z plane. This wall behind me becomes the x plane. That wall to my right becomes the y plane. Got it?
Yes, sir.
Now the intersection of all these three planes, give rise to what? Intersection of all these planes give rise to what? Come on fast. It gives rise to the axis, three axes, right? It gives rise to the three axes. Correct. Okay, so the x plane is there and the y plane is there, right? X plane and y plane. That will give rise to z axis. Okay, x plane with z. X plane with z will give rise to y axis, right? And the remaining one is x axis. Got it? Now the intersection of the three axes give rise to what? To the origin. Got it? So now you see, please appreciate and understand now. Then only you can understand. See, mathematics is not just using formulas and trying to solve sums. Physics is also not using formulas and trying to solve problems. You must understand the conceptual build-up. So right now you see, I have z plane under my foot, x plane behind me, and y plane to my right. Do you appreciate that?
Yes, sir.
Now I want to locate this point P. So what do I do? I will take a plane which is parallel to this x plane and move it. And this plane is x1. I will take a plane parallel to y plane and move it. That becomes y1. I will take another plane z is equal to z1 and move it here. So what will happen here? Again, three planes which are mutually perpendicular to one another will meet at this point P. So this point P, when I say it is x1, y1, z1, it means what? There is a plane called x1 which is parallel to the plane x is equal to 0 and it is moved parallel to that, parallel to this. You are locating the point. This is how you are locating the point, frankly speaking. Correct?
Yes, sir.
Okay, fine, thank you. Now, this is, I told you, Cartesian coordinate system. Cylindrical coordinate system. What is cylindrical coordinate system here? Again, you see, Cartesian coordinate system, cylindrical coordinate system, spherical coordinate system. In all these three, you are going to have three planes which are mutually perpendicular to one another and they cut at that point. Correct? So in this, there are three planes which are mutually perpendicular. They cut at the point. You got P, X, Y. Now here you see what happens in cylindrical coordinate system. you will take a, so in cylindrical coordinate system, you will have this plane, which we call it as Z plane. Got it? It's a plane. This ground is a plane. Got it?
Yes, sir.
This ground is a plane. This is Z is equal to 0. Right? And obviously a perpendicular line drawn to this becomes the Z axis. Okay? Right. Now I want to locate this point. So what do you do? What do you do? What do you do? I will take a plane parallel to Z is equal to 0 and that is equal to Z is equal to Z1. So I will place a plane here. Got it? So I have taken a plane Z is equal to Z1 and I have placed it here. Correct? It is going through this point P. Hello?
Okay.
Yes, sir.
Then you see. Now you see. So this is. So there is Z is equal to 0 and I have placed a plane here perpendicular to this and this is cutting this point P. Got it?
Yes, sir.
Then I will take a cylindrical surface with Z axis as the axis of the cylinder. Got it? Cylindrical surface.
Yes, yes, yes.
And this cylindrical surface is passing through point P. Got it?
Yes.
So there are two planes now. One is Z is equal to Z1 and another cylindrical plane. Both are cutting at this point. Got it?
Yes, sir.
Done. Now you see what I do. I will take a plane who half plane. Half plane means what? It's one side is touching this, other side is like this. Other side is like this. Half plane. Got it?
Okay, yes.
This is the half plane. One side is touching here, other side. But it is infinite. So I will take a half plane like this. Got it?
Yes, sir.
And this half plane I will give it the name phi is equal to 0. So I got three planes here. Z is equal to 0, phi is equal to 0, and another surface rho. Another surface rho. Rho means what? See, it is I will have a cylindrical surface. I told this cylindrical surface will have some radius. Got it?
Yes, sir.
So when I say cylindrical surface of radius rho, cylindrical surface of radius rho. So at this point, one plane is going like this, another half plane will also cut this point. Okay, and then of course another cylindrical plane, okay, will also cut through this point. So there are three planes. Which are the planes? Z, phi, and sigma. So sigma represents what? The radius of this cylindrical surface. Phi represents what? Now, if you take this as phi is equal to 0, then the plane going through P becomes phi is equal to phi, or phi is equal to phi 1. Got it?
Yes, sir.
So the coordinates of this point will be rho, phi, and z.
So how phi is decided? Can
So you create a reference. What do? I will stand here and take a half plane. I will call this as phi is equal to 0.
okay.
Right? And another plane, I am taking it like this and moving it like this. So this becomes, the angle made by my hand now becomes what? Phi is equal to phi. Now this is phi is equal to 90 if I have a plane like this.
Yes, yes.
So that is how you locate the point P. This is cylindrical coordinate system. Understood?
Yes, sir.
See, this I have taught you. See, with the help of this only, we were able to say the electric field. See, if you have a conductor, straight conductor, what is the electric field at this point? It is a straight conductor which is charged lambda. What is the electric field here? Right? You remember? What is the electric field here? The electric field here, right? See, electric field here. Now you can write it. See, you can write the components of the electric field here in terms of x, y, z. In terms of x, ax cap plus y, ay cap plus z, az cap. You can write this. The electric field at this point. Due to this, the charge conductor. You can write like this. Correct?
Yes, sir.
A, hello.
Yes, sir.
Huh. But now it is difficult because X, Y, Z components are difficult if you apply your mind here. Huh. But if you consider cylindrical coordinate system, the electrical field at this point, the electrical field, and I am telling you, this is an infinite conductor. So you know the electric field here is like this. E bar is like this, if it is infinite conductor. So obviously now, what will be the coordinates of E5? See, E bar would have got, what are the coordinates of E bar I would have got here? I would have written here, sigma A sigma cap plus phi A phi cap plus Z A Z cap. This is how we would have written. But now, as far as the electric field is concerned, it is only in the direction of sigma, because see, if this is a conductor which is uniformly charged, then the electric field everywhere is like this, perpendicular to this. Got it now? So therefore, the electric field at this point will not have these components. The electric field at this point will simply have what? Sigma A sigma. Simple to say. So if you are a long straight conductor, the electric field is this. Sometimes the sigma is also written as R. R by Z. Or in that case, the electric field at all the points. See, if you take these points, the electric field at this point, this point, or any point like this. Okay, it's going to have what? It's going to be what? It is going to be R. It is going to be R A phi cube. Hello, that is the electric field. These points will simply be in the direction of what? Will simply be in the direction of R cap. Are you with me? Okay. Now you remember. See, what is the electric field at this point? You remember? Lambda divided by S 2 pi epsilon naught. Correct? 2 pi epsilon naught R. That is what you used to write. If the distance from this is R. Hello, are you with me?
Yes, sir.
So now, what is the electric field at this point? I'll write here. E bar will be equal to lambda by 2 pi epsilon naught R cap. That means it is perpendicular. Got it?
Yes, sir.
Any question? If you use this, your life becomes Jingalala, and you have to use this. Then only you can solve difficult problems in main, and in advanced at least you should use this coordinate system only. Then only you can solve the problem quickly and effectively. Any questions here? This R cap is a constant. You know that now?
So that will be ER cap.
I have written R cap. You write it as ER. Okay.
No.
Okay, right. I can use that. Yeah. Okay. Sorry. It is a constant. Got it now? Okay.
Yes, sir.
Don't we need to like specify other things about that point?
What other things you want?
Like that pi, like if you take a reference and decide pi and
Why do you do phi? See, now if this is a long straight conductor, lambda, I want the electric field at this point. Electric field at this point. So electric field at this point will be in this direction. So I'll write here lambda by 2 pi epsilon naught R cap. Or no? You have some doubt?
No, sir, that direction of AR cap.
So you see, this boy has got some confusion. Good, you should have. What I told is wrong. R cap is not constant. See, R cap here is R cap here. But if I want to show the electric field at this point, this R cap is different from this R cap. So I should write here R1 cap, R2 cap, R3 cap, R4 cap. Got it? It's the radius vector. It will be different. So R cap vector is not a constant. It is only telling, R cap is only telling that it is along the line perpendicular to this axis.
Yes.
Got it? So in general, what I want to say is the electric field around this point is given by this. So what it only conveys? What is the meaning it is only conveying? that the electric field at all these points at a distance r from here has got magnitude this, and it is in the direction perpendicular to this line. That's all it is conveying. Correct?
Yes, sir.
See, now you see, now if I have got a point charge, point charge Q. Okay, what is the electric field at this point? Why are you taking so much time, man? What the hell? And only you are trying to answer. What about others? You have forgotten, eh?
That is perpendicular to the sphere.
Hey, I have just shown one point charge Q here, and I am asking you what is the electric field at this point.
Along the line.
Arey yaar, tell me, E bar is equal to what? See, this is where our education system has failed. Failed. I have written E bar. See, this is the problem with our education system. You have solved IIT advanced level 1000 problems. And now I am giving you a simple situation. This is Q and this is E bar. What is the electric field at this point?
Sir, it will be KQ by R square. Where R is the distance.
So first, see, come on, yaar, you are physics student. You are physics student. Let the distance from this to be R. Then E bar of R bar will be equal to KQ by R square. Or if you are a good student, you will write here KQ by modulus R bar square, okay, into R cap, where
Yes, sir.
where R cap is what? R cap is
R cap will depend on the magnitude of the charge, sir. And
ಏನು magnitude of the charge ಬಾಯಿ ಬಂದಿದ್ದು ಹೇಳಾಕತ್ತಿಲ್ಲ.
sorry, sign of the charge. Like it is
Sign of the charge ಬಾಯಿ ಬಂದಿದ್ದು ಹೇಳಾಕತ್ತಿಲ್ಲ. When we write Q means it is plus Q. Confusion king. So where R cap is a unit vector, okay, along the radius with charge Q at the center of a imaginary sphere, where R cap is a unit vector along the radius with charge Q at the center of the imaginary sphere. Correct now?
Yes.
Why you didn't tell? I am telling all of you. See, this is what is the problem. You go on solving problems from the modules and you have learned nothing if you do like that. You learn concepts first and then use the concepts and solve problems. Then only educate, that is education. Right? So R cap is a unit vector along the radius with charge Q at the center of the imaginary sphere. Got it? This is right. Whatever I have written, something else is missing here. Hey!
K is equal to
K is equal to fine. You have to write K is the constant of proportionality. Right. But in this definition, something else is missing. See, R is radial means what? It can be like this also, it can be like this also, no? So what do I mean here? R cap is?
the direction of
Mata?
from
It
the
is,
point
where R cap is a unit vector on the radius with the charge at the center of the imaginary sphere and what? Radially outward. See, if you think like this, If you write like this, then you are doing physics. Otherwise, God knows what you are doing. Come on, all of you change your attitude. Come on, be brave and bold and start using science, for heaven's sake. Okay. Concept of concept. Now, what is R cap? It is a constant. Yes, no?
R cap can't be a constant, sir.
R cap cannot be a constant. Understood? No? So already we have dealt with it. So it is only telling you that it is radially outwards. That is it. Nothing more, nothing less than this. Clear?
Yes, sir.
So this expression only means if you place a point charge Q at the center of an imaginary sphere at any point at a distance r, the electric field magnitude is this, and it is direction. It is along the radial direction outwards. That's all it is conveying. Nothing more, nothing less. Now coming to spherical coordinate system. So spherical coordinate system, I am going to locate the point P. Okay. Now listen here. R, theta, phi. These are the coordinates. Now quickly I will tell. If you can understand, you understand. If you don't understand, God save you. Now you see, I want to locate a point here. I want to locate a point here. Correct? Now say yes, yes, yes. So assume that this button, can you see of mine? No, you can't see. This button, can you see? You can see. Correct? So consider that this button here is the center of a sphere. This is the center of a sphere. Got it? So I want to locate a point here. I want to locate a point here. So what will I do? From this center of the sphere, I will draw a cone. Can you see a cone?
Yes, sir.
This is the cone, and the conical surface is going through this point, right? And this conical surface will be like this. So if you draw an axis like this, this conical surface will make an angle theta. Got it?
Yes, sir.
Okay. Now quickly learn, if you can learn. So this is making an angle theta. This is the center of the sphere. First is that I want to locate a point P here. Then through this point I will pass an imaginary sphere of radius r. Got it?
Yes.
So there are two planes which are cutting this. One is the conical plane, another one is the spherical plane, and they are mutually perpendicular to one another. Got it? Now the third plane. What is the third plane? So again, through the center I am drawing an axis. Through the center of the sphere I am drawing an axis. Okay. Then just like cylindrical coordinate system, I will consider a half plane. Half plane. And this half plane I will rotate it through angle phi. So this is also going to cut this point. Got it?
Okay.
So I have located this point. So this is P, R, theta, phi. These are the coordinates. Got it?
Yes, yes.
Done. Okay. Now you see. Now if I take, now assume that, okay, there is a sphere here. Can you see the sphere here? This sphere, it can rotate. So definitely this is the axis, right? Now if I want this, see, now you can see our Bharat Mata here, Earth. Okay, so if I want to know what is the area of this part of the sphere, what is the area of the part of the sphere? Okay, hello, are you with me?
Yes,
sir.
So how will I locate that area? Now see, watch out quickly. So I'm pointing to that area. This becomes what? R.
yes.
Now R d theta. R d theta. This line.
Yes.
R d theta. This line. Now you see. This is R. This is, see, now this is R. This is theta. This line becomes what? R sin theta. This line becomes R sin theta. Got it? If this is R and if this is theta, this becomes R sin theta. Got it?
Yes, sir.
Now I am telling you this is R sin theta. So this is R sin theta. So this half plane, you see here, this half plane will rotate by angle phi. will rotate by angle phi. Okay. So therefore now see here r sin theta d phi. So I get here r d theta into r sin theta into d phi. So see, I want to mark a patch on this. I want to mark a patch on this. What is the patch? One is r d theta, another one is r sin theta d theta. R sin theta d theta. I am marking the patch. So therefore, what is the incremental area? dA will be equal to r d theta into r sin theta d phi. What is this incremental area? Correct?
Why R sin theta?
See, gentlemen. See, now this is r, this is theta. Correct? This becomes what? This is r sin theta. Correct? See, I want to run the painting brush like this. See here, I want to mark this patch. I will run the painting brush like this. R d theta. I have painted like this.
Yes, sir.
I want to paint like this. Like this I want to paint. So for this now, this is not the R. I should consider horizontal. I will keep the, see, I want to keep the painting brush horizontal. Correct? So R sin theta d phi. I will paint it like this. Then I will get this patch.
Yes, sir.
Good. Okay. So now you see, having got this area, now you see, I want the total area of the sphere. I want the total area of the sphere. So therefore now I will have to integrate this two times. One for phi and another for theta. Correct?
Yes.
So this will be phi is equal to 0 to, see, I want to paint it full sphere, to phi is equal to 2 pi.
Yes, sir.
And theta will be 0 to theta is equal to what? This theta, see here, this theta will be 0 to this only, because both sides it is spreading. Theta is equal to theta to pi. Correct?
So the theta will be theta to 0. No?
Theta 0, see, now you see, I am the center of the sphere. This is, and this, my hand is cold. Theta is equal to 0, agreed? Now theta is equal to 90, agreed?
Yes.
Now theta is equal to 180, agreed?
Correct.
That's what I want. Pi.
It won't be pi now, sir. Why pi?
Then what is this? This is pi by 2. This is pi. Theta is equal to 0. Theta is equal to pi. Theta is equal to 0. Theta is equal to pi by 2. This theta is equal to pi. 180 degrees, no man.
Yes,
Huh. So if I bring this quantity here, r square will come out because r square is constant. The radius has not changed.
Yes.
Okay, now I have to integrate these two. What is it now? First is sin theta, d theta, and d phi. So I can do one of the integration. I can do integration with theta first or with this first. If I do with this first, so integration phi from 0 to 2 pi will simply become what? R square into 2 pi. It will come out.
Yes, sir.
Now integration of sin theta d theta. What is it going to be? It is going to be cos theta. Minus cos theta. Okay. Minus cos theta. Minus cos theta. It's okay. It's minus cos theta. Right. Minus cos theta. And this is going from 0 to 2 pi. Right? So this is going to be what? R square 2 pi. And what is this going to be? 2 pi becomes what? 1.
0 to 2 pi. 0 to pi, sir.
0 to pi. Sorry. So cos pi is minus 1. Minus into minus becomes plus. Correct?
Yes.
Okay. Wait. This is minus. Into 2 pi I have written. Now this minus I will take it outside. then into this cos phi is minus 1. Hello, minus of cos 0 is 1. Got it? So what will I get here? This becomes 2. So I get here 2 into 2, 4. 4 pi r square. Is it not the area of a sphere, surface area of a sphere?
Yes, correct.
Okay, okay, got it. Done. Dhanyosmi. Right. So this is the surface area of a sphere. This is the surface area of a sphere. Got it? Now, what is the volume of a cube? So dV. So therefore, here you have to multiply it by what? For volume of a cube into dr. Thickness.
Volume of cube, sir.
Volume of a sphere. So now what we have calculated is surface area. So surface area into dr gives you dV. So you have to only multiply it by dV. You have to multiply it by dV. So one more integration will come here. So you will have 3 integrations. So this is going from r is equal to see this is for the radius r. These two are theta and phi. Just now whatever we did. Hello, whatever we did. Whatever we did. Now here r is not going to be constant. So inside the integration you will have r square coming inside. R square is going to come inside and dr will also be there. Hello, are you with me? This is r is equal to 0 to r. So this term will get multiplied by what? This term will get multiplied by r cube by 3. Okay, so therefore this will be 4 pi r square into r cube by 3. So that's how you get 4 by 3 pi r cube. Got it? So this is how it is. So I have taken this example to see these are all trivial things. By this time you should be perfect in all these things. If you are writing examination, mains examination or NEET examination by this, because you please understand now all of you, it is not just about solving a sum in the examination, how quickly you solve and how quickly and efficiently you solve and how correctly you solve. If you use the right technique, right concept, then your answer will be correct and you can confidently mark it. Otherwise, you know, if you mark the wrong answer, then you are going to lose marks. So you must develop this attitude, mindset, and the skill set you should have to solve. Anyways, so I think I have explained the spherical coordinate system to all of you. Done. Okay, so now let's come to our problem. Here. So you can find the area of this sphere now. So now you can get theta from this. You got theta from this. Hello?
Yes, sir.
And the radius is known to you. R is known to you, theta is known to you. So you are just now done the integration of man. For your integration was what now here? Okay. Phi was going from 0 to 2 pi and theta was going from 0 to pi. Now you will not go from 0 to pi, you will go up to this theta. Cos inverse of r by r plus theta. That's all. So here you will get r square into 2 pi into, your theta will go from 0 to this. So there sin theta becomes cos theta. Cos inverse of cos of this becomes what? Hello, are you with me? 81 plus cos 0 is 1. Okay, so this is going to be the area covered by this. This one. Anyway, I hope you understood something.
Yes, sir.
Yes, sir.
ನೋಡಪ್ಪ ಪ್ಲೀಸ್ ಕಲಿಯೋರು ದೋಸ್ತರ ಹೇಳಿದ ಮಾತು ಕೇಳ್ರಿ ಸಮಾಧಾನ ಕಲಿಬೇಕು ಒಳ್ಳೆ ಹುಡುಗರಾಗಿ ಓಕೆ ಸುಮ್ಮನೆ ಏನೋ ಒಂದು ಕಲ್ತು ಪಾಸ್ ಆಗೋದಲ್ಲ ಜೀವನ ದೊಡ್ಡದದ ಲೈಫ್ ಇಸ್ ಬಿಗ್ ಯು ಹ್ಯಾವ್ ಟು ಹ್ಯಾವ್ ಪರ್ಫೆಕ್ಟ್ ನಾಲೆಜ್ ಯು ಶುಡ್ ಬಿ ವೆರಿ ಗುಡ್ ಸ್ಟೂಡೆಂಟ್ಸ್ okay don't simply somehow I solved this, I did that chapter is important, this chapter is not important hangella kalibardu. You cannot become doctors, engineers and scientists. Okay, yes, nowadays you see you will get as soon as you complete engineering, some Australia, America, some England, somebody will offer you some job, MNC. oh, then you will feel very proud and elated. Oh, I got a job in US, Yahoo, and all those things. They are just using you. They will make you to work for 14 hours a day till you are 30 years. Okay, and then they will throw you. See now, layoffs. Many people who went to US, even students all over the world, they are in ditch. They are thrown out of the university. They are thrown out of the job. What will you do? See, remember, that part of the life is difficult. Now your parents are feeding you. You have to feed yourself and you have to feed your family. You come to the roads. Understand? So it is difficult. So therefore, if you have knowledge, then you will be very strong. You don't have to depend much on others. You know what is your capacity, you can build. And those people who have perfect knowledge, they will survive at any time, at any point of time, anywhere in this world. Those who have got this bookish knowledge, maybe for this instant, they might look big. But it's a hollow claim, big trouble. That should not happen to you. So learn very, very seriously, very briskly. I am there to teach you. You should take help from me. That's it. Okay. Oof. Right. So, some moment, I want all my students to lead a very good life. Line of sight combination, there is no physical obstruction in this. So, height of the antenna is. Okay. Transmitting and receiving antennas at the same height given antenna, radius about this, for the range. So, here you see, for the range D is equal to, I hope you
Okay,
1 minute, okay? Let's try this. I taught you spherical coordinate system. Just check it out. For the range D is equal to 2RH. Yesterday that formula was there. I hope you remember that. See, yesterday, I suppose you can open your textbook and see that formula. You had one antenna here and another antenna here. You remember this distance was dm. Okay, this was the height of the transmitting antenna. This was the height of the receiving antenna. Hello, are you with me? So you calculated dm equal to, I suppose you had calculated dm equal to, right? Okay, sorry, dm equal to, what is it? It is root of 2 r, dm was equal to root of 2r ht plus root of 2r hr. Remember? Now in this case, we want the range here, only up to this point. This antenna is not there. So you can consider that this antenna is here. So this quantity goes up. Got it? So you are getting this range. Okay. So this is the maximum. That means now an antenna placed here, everywhere, or anywhere placed in between, it will get the thing. I taught you there to understand that the area. So how much service area it can cover with the receiving antenna. I taught you spherical coordinate system how to calculate, but using this formula you can directly get it. Okay, for this problem it is okay. For some other problem, more complicated problem, you might have to use spherical coordinate system and handle it. For this it is okay, right? So now here you see dm is so much, and therefore dm square becomes 2rht, right? And what is the area? So area becomes this area. So here he is calculating the area of a circle only. See, here the service area is area of this, he wants to know to what range, right? How much service area can it cover?
Yes.
Now there is a mistake here. This should be what? This should be d square. Hello? This should be d square. Hello, are you with me?
What?
This formula is correct for range. D is equal to 2RH is better.
Root of d square.
D square ಲಘು ಲಘು ನೋಡ್ರು ಏನು ಹುಡುಗರು ಬರೋದು.
Yes, sir, it will be discussed.
ಅದಕ್ಕೆ ಡಿ ಸ್ಕ್ವೇರ್ ಬರ್ತದೆ ಇಲ್ಲಿ. ಏರಿಯಾ ವಿಲ್ ಬಿ ಎನ್ ಡಿ ಸ್ಕ್ವೇರ್. ಓಕೆ, ಸೊ ಹಿಯರ್ ಇಸ್ ರಿಟನ್ ಕರೆಕ್ಟ್ 2RH. This is not, what is this? This is pi d square. This pi pi d square. So he is calculating the area. He is calculating the area of the circle. He is calculating the area of the circle. Okay, that is covering the range. That is covering the range. He is not calculating the area of the sphere. He is calculating the area of the circle. So if I know the circle, everything within this circle I can access it. That is the idea behind this. Okay, got it?
Yes, sir.
Other. Quickly, a carrier wave of peak voltage 12 is used to transmit a message signal. What should be the peak voltage of the modulating signal in order to have modulating index of 75%? You know what is modulating index? Yesterday I told you. Modulating index.
You know, sir.
Mu is equal to what? AM upon AC.
Yes.
AM upon AC.
That's it.
So here they are giving you AM is equal to 12 volts. Okay, and AC we don't know. But it should be 75%. That means this should be 3/4. Modulation index of this. What should be the peak voltage of the modulating signal? Sorry, carrier. Sorry. So this should be AM upon 12. Okay? Got it?
Yes, sir.
So what should it be? Very simple. So here 4 3s are 9. AM should be equal to 9 volts. Should be the answer. Yes. Yes, correct. Modulating square wave. See, we have done the theory with the sinusoidal signal. Now modulating is a square wave. Square wave shown in figure. The carrier wave is given by 2 sin 8 pi t volts. Sketch the amplitude modulated waveform. What is the modulation index? Can you sketch it?
Yes, sir. Yes, sir.
Did? Not so much. Not so much is sufficient. Okay. So here you will have the carrier waveform. Got it? It should look like this, like this, red color. But of course, here they are giving this one also. What is it now? Period. It is 1 second, 2 seconds. It is 2 sin 8 pi t. So now 8 pi t. So what is the period here? What is the period? So the period of this modulating signal, is 1 second. What is the period of the carrier? Hello? What is the period of the carrier? So this amplitude of the carrier is 2. amplitude of the carrier is 2. So this should be 2 units. Plus and minus 2 units, first of all. And what is the period?
So that should be A plus AC and AM plus AC and AM minus AC.
Pardon, once again, come again.
So those amplitudes should be AM plus AC and AM minus AC.
AM plus AC, AM
Plus AC. It will be like that, no? Like that envelope. So that amplitude should be 2 plus 1, no? Okay, I've marked one.
Correct. See, you are telling me 2 plus 1. So this should be, from here to here, you say this should be 3.
Yes. And that the lower one should be 1.
Lower one should be 1. Upper one should be this. No, they asked you to sketch. Asked you to sketch only if you see the components. In the components, you are going to have that. Okay, I am just sketching it once again. What is this time period of TC carrier? So 8 pi represents what? Omega is equal to 8 pi. Right? Omega is equal to 8 pi. So omega is what? 2 pi f or 2 pi by t is equal to 8 pi. Pi cancels, 2 under 2 4. Okay, so t is equal to what? T is equal to 1 by 4. So it will be 4 times. That means from this point to this point you should have 4 variations. 1, 2, 3, 4. Not the 5th variation. Got it? So from this point to this point you should have 1, 2, 3, 4 waves only. 4 of the carrier. Got it?
Yes.
Now as far as the height is concerned. So what about the height?
So height should be 3 and 1.
3 and 1. I have written 2 plus 2. I have taken the center here. Okay, let's see. Okay, don't worry. We will see it. What is the modulation index? Modulation 1 by 2. Modulation index is 1 by 2. No doubt. 50%. Okay, let's quickly see the answer. See, there is time constraint. I am actually not able to enjoy this problem the way I could have enjoyed it. But anyway, we have to live with it. Right? Tm is equal to 1 second. Angular frequency of the modulating signal is as follows. Okay, so we got this omega 2, it is 8 pi by x, 4 omega, the amplitude of the modulated. See, it is plus 3 and minus 3.
Yes.
Plus 3 and minus 3. Got it?
Yes. So plus 3 and that should be 1, no, sir? And lower one.
No. See, they have taken the 0 here. They have taken the 0 here. They have taken the 0 here. This is plus 3 and minus 3. So it will be 2 plus 1, 2 minus 1. 2 plus 1, 2 minus 1. Got it? See, what I have written here is also like this, man. See, what I have written here, you saw here. See, this one is 1 unit. Right? And from here to here, I have taken it as 2 units. So, of course, I should have written from here to here 3 units, 3 units. Okay? Correct. I have written it, sketched it properly, but I calculated it wrongly. Anyways, that's a mistake. Right. Modulation index is 0.5. Got it. Done. See, you are going to get questions like this. So, superficial reading, no. See, these questions are absolutely based on your NCERT. No doubt about it. Whatever it is, I am doing my best. But you should take benefit out of it. For an amplitude modulated, okay, solve this. Hope you understood this problem. See, now you understand the meaning of this word aptitude. So here, so they are told you this value. They are telling you this value and they are telling you this value. So this value they are told is 10 and this value they have told is 2 volts. Got it?
But
So either way you can divide it into 2 and 2 or other. What is the modulation index? What is the modulation index?
2 by 3.
2 by
3.
3.
3.
2 by 3.
Series suitable.
Hmm? By 3 will for the amplitude the maximum amplitude is 10 volts while the minimum amplitude is 2 volts. Minimum amplitude is 2 volts. We are taking it like this, 2 volts.
Maximum amplitude is AM plus AC, sir.
ಅಲ್ಲ ಇದರ ಇಂಟರ್ಪ್ರಿಟೇಷನ್ ಕರೆಕ್ಟಾಗಿ ಮಾಡಬೇಕು. ಇದರ ಇಂಟರ್ಪ್ರಿಟೇಷನ್ನ ಕರೆಕ್ಟಾಗಿ ಮಾಡಬೇಕು.
What are done is correct.
One minute, let me think. ಇನ್ನೊಂದು ಸ್ವಲ್ಪ ಇದೆ, ಬರೋಬ್ಬರಿ ಇರ್ತೀನಿ. What does modulation index mean? Modulation index means so we got there AM by AC. AM by AC. What is modulation index? Okay, see this theory is not given in the NCERT textbook. I beg to differ. So see, the modulation index is given as the maximum amplitude, okay, amplitude minus minimum amplitude divided by maximum amplitude plus minimum amplitude. Okay, now let me explain this. This is the envelope. This is the amplitude of the envelope that we are talking. Hello, are you with me?
Yes, sir.
This is the amplitude of the envelope that we are talking. Okay, so this is the actual definition of U. I remember this, okay. So therefore I am writing like this because okay, what they have given there is for a single sinusoidal signal, we were writing it like this, okay, but the true meaning of the true definition of the modulation index is like this, okay. So according to this should be what? This should be 10 minus 2 divided by 10 plus, so this will become 8 by 12. So this becomes how much percentage? So 4 2s are 4 3s. So that is approximately 0.66%. Correct? Modulation index.
By using AM by AC, we get this.
By using what?
AM by AC.
AM by AC also you get the same value. Yeah? What is that AM you have used?
It's a AM plus AC is 10, sir. AM minus AC is 2.
Okay, same. See, it will come down to the same formula. Correct. Okay, got it. You have understood it correct. Correct. You have understood it correctly. Done. But this is the original formula. Easy to calculate. Okay, you get 0.63. You determine modulation output to the value if the minimum amplitude were to be 0. Then the modulation index is 1. Okay? Hello? Yeah. So we will proceed. Let us see whatever we already write down. Yes, what we already discussed. You see, the formula is this. What I have written is correct. Go with this. But if you have captured it correctly, what I have written there is correct. Due to economic reasons, only the upper sideband of EM is transmitted, but at the receiving station, there is a facility for generating carrier. Show that if a device is available which can multiply the 2C, it is possible to recover the modulating signal at the receiver. Yes, yesterday I told you this. With the diagram I have explained this. Now you should be able to solve this. That is, you will not transmit the full. You will not transmit all the 3 components. You will only transmit the sideband. Correct? And at the receiver, there is provision to generate the carrier. That also I have explained to you. So, show that the device available, we can multiply the 2 signals. Such a device is available, we can multiply the 2 signals and it is possible to recover the modulating signal. Okay? That means now, you have now got, you write the, this one, see, you have done the derivation for amplitude modulation, you remember? And derivation, you got cos of, yesterday you got cos of omega c minus omega m. You remember? And this side you got what? Mu AC by 2. Correct? As one of the segments. Hello, are you with me?
Yes.
You got this expression yesterday?
Yes.
Omega c minus omega m by 2 or only omega c minus omega? Only you got omega c minus omega, correct? Hello? So this is one signal that is entering. You remember yesterday? And we have written a plus sign and we have to pass here another signal. What is what? It is something like, AC sine of omega c. So now if you multiply these 2 signals, you should be able to generate only omega m. So multiply these 2 and see.
Minus K plus.
Okay, minus. Because you are subtracting it, it's minus. Okay, but actually what are you doing here? You are doing the multiplication of these 2. Correct? So if you multiply these 2, what will you get here? So again here. So you just take this cos of omega c minus omega m into sine of omega c. Omega mt into sine of omega. Got it? Hello? So if you multiply cos and sine, so you have to take 2, isn't it? 2 sine A cos B. 2 sine A cos B. So 2 sine A cos B will give you what? You split it. 2. So this is what? Something like sine A cos B. Correct? Hello? So when will you get this term? 2 sine A cos B. Sine A plus B. Correct? Sine A plus B. You will get this. So if you multiply these 2, so what will you get here? Sine of Tan of A plus B, no? What is it going to end up? So, multiply it is possible to recover the modulating signal at the receiving station. You understood?
What should we get after we multiply, sir? What should we get?
That's what you should get the modulating signal. See, now either you take plus or minus, either or. Okay, you take plus. Assume that you take plus. So if I multiply these two signals, I should get here one signal which will only contain, see here, one signal which will only contain, say, some A1 into sine or cos. Okay, you take cos here, because both you take it as cos omega ct, then things will become simple. See, I should get one component as A1 cos omega mt and another component A2 which will of course contain cos of omega c plus omega m, something like this. Okay, so I am going to get at the output two components, one this component and one this component. Got it? Hello?
Yes, yes.
So this component now is having frequency omega c plus omega m. This component has got only omega m. So what did I tell you yesterday? You should just have a low pass filter. You should just have a low pass filter. The low pass filter will only pass the lower frequencies. Higher frequencies will be attenuated. That's all. Okay, see here, omega ct, if you multiply these two. Okay, so sine was not giving me the proper this one. Cos what is this combination going to be? What is this combination going to be? Cos A, cos B. Hello?
Cos A plus cos.
Cos A, cos B. Tell it. In the sine A, you take it as cos A, cos B. What is it? Cos of?
Cos of B.
Louder! See, this is, if you multiply these two, man, you are going to, cos of omega c plus omega m into whatever be the constant. Forget it. Cos of omega c t. So what is this? If you split this, cos
Cos of A plus B minus cos B.
Tell now. Tell now what is the problem? Cos of A plus B minus cos of A minus B. Is that it?
Yes.
Here so cos of A plus B will be what? You will get become cos of 2 omega c plus omega m into t plus another term will be cos of omega c minus omega m, it will be cos of omega m t. Correct?
Yes, sir.
So I got two components, one this, one this. So you pass a low pass filter. Low pass filter with cutoff frequency at omega m. So that is the low pass filter with cutoff frequency omega m. Okay, so only these frequency will only come out. Other frequencies will be filtered. That's it. Over. Okay. See, yesterday only we discussed this theory. See, that's what I'm trying to tell you. See, there was a derivation. Based on the derivation, the examiner can think, if the student has understood this derivation, he should be able to solve this problem. That's the whole idea. So, if you had if you had seriously taken my classes seriously, today you would have solved it. But for you, no, you solve problems that we learn. I have solved this problem. In examiner, he knows. If you have not understood this, he knows how to make it to how he knows how to find a question and bring out the best from you. So please learn properly. Okay, let us see the answer. Okay? Say we have whatever. He has used omega S there, this one so and so. So he is able to filter. At the receiving station, the low pass filter allows a high frequency to pass through it. Allows only high frequency to pass through it. It obstructs the low frequency omega. Thus, the receiving station only can record the modulations. Okay. Got it?
Sir.
Yes, sir.
I am going to take slightly more today. Anyway, you are not going to college. Oh, done.